Welcome to Smart Manufacturing, moving from static to dynamic manufacturing operations. I'm Jonathan Miller, and we also have with us Dr. Brian Anthony, professor at MIT. This is the introductory overview of this MIT professional education course. So before much ado, I want to get to introduce Professor Anthony. So Professor Anthony is a principal research scientist within MIT Mechanical Engineering. He's also got quite the laundry list of other achievements and titles: Associate Director for the MIT Nano project, Director and Master of Engineering in the Advanced Manufacturing and Design program, also at MIT. He's got more than 25 years of experience as an entrepreneur, focusing on commercialization, product realization at the intersections of fields like information technology and advanced manufacturing. This has caused him to be able to generate 20 patents and published widely in peer-reviewed journals. Perhaps my favorite achievement is Professor Anthony has been awarded an Emmy from the Academy of Television Arts and Sciences. And this is for some specific innovations he's achieved in sports broadcasting. And so let's give the floor over to Brian Anthony.
Very good, Jonathan. Thank you. And good morning or good evening or good afternoon, depending on where you are in the world. Just want to take a little bit more time to introduce both myself, a little bit the manufacturing context, both at MIT and in the ecosystem around MIT, and then dig a little bit into the high level of the smart manufacturing course that I hope you're choosing to join. Just a little bit of overview about manufacturing at MIT. I'd say the motto of MIT is mind and hand, and manufacturing and design is an ethos that is woven throughout most everything that we do. But there are a number of both labs and centers that are very focused quite specifically on manufacturing. Today I'm sitting in Building 35 at MIT, which is the Laboratory for Manufacturing and Productivity. It's a collection of faculty and researchers and students and postdocs that are looking at everything from product design to new processes to manufacturing systems to supply chain, and it's also the home, or the headquarters, if you will, for our Master of Engineering in Manufacturing program. As well, there are a number of other centers and labs across campus that are very much involved in various aspects of manufacturing. There's the MIT Energy Initiative, which also helps to lead an effort looking at how to save energy in the large energy-consuming manufacturing industries. There is the Laboratory for Information and Decision Systems, the Institute for Data Systems and Society, which they deal with all types of data, but certainly the types of data that come from manufacturing environments. And then we do biomanufacturing, chemical manufacturing, looking at processes, materials. So there's a very deep and rich bench of experts, both in the education that we do and the research that we do and the students that we educate, that are really moving into impactful roles in the manufacturing sectors throughout the U.S. and throughout the world. As well, I would argue that manufacturing is the way that you will ground innovations into an economy, and MIT prides itself on highlighting that if we were to take all of the startup companies that have spun out of MIT, we would be equivalent to the 10th or 11th world's largest economy. And that ecosystem of entrepreneurship is not formally structured. There is no singular office that houses all of our innovation, all of our entrepreneurship activities, but we have a smattering of all different types of both clubs, funding opportunities, mentoring opportunities to provide both instruction in entrepreneurship, to provide insight and guidance to companies that are being formed, and provide some seed funding, sometimes, small numbers, but seed funding to help the researchers, students, and faculty get the technology out into the marketplace. And so it's heavily involved not only with manufacturing and product design, but broadly throughout. But there's certainly a strong emphasis on the physical systems that come out of the research and the things that we do at MIT. Now, expanding the sphere just a little bit, focusing on these three graphics. If you've not heard of these, there are what's called manufacturing innovation institutes, and there are over 15 of them across the U.S. now. They're somewhat modeled after the Fraunhofers, if you're familiar with those, but they are intended to sit between academia and industry, and MIT is heavily involved in a number of them, and not just the three that I'm highlighting here, but I highlight three here just to give you a feeling for the vibrancy of the business and the research that is manufacturing. And there's constantly innovations that are arising, and the pipeline of technology and the pipeline of talent from university to practice, to commercialization, is reinforced by these manufacturing institutes. And the upper left corner is an image of a flexible electronic circuit. That's to represent a NextFlex. That's not Netflix. NextFlex is the manufacturing institute that's focused on making flexible, deformable electronics, everything from the inks and the materials to the manufacturing processes, and MIT has a heavy involvement with that. The bottom graphic is to denote AIM Photonics. That's the Integrated Photonics Manufacturing Institute, whose existence is really to try to look at how do we take the existing stack, if you will, of technology in the semiconductor industry. Everything from design of integrated circuits that pipe electrons to how do we now design integrated photonic circuits that pipe photons, to how do we use the fabs, to how do we use the design tools, the packaging tools, to make now not just microelectronics, but microphotonics, and have both of those functionalities on one substrate. And then the upper graphic, the upper right graphic, is to denote FOA, that's the Advanced Functional Fibers and Fabrics of America. That's looking at how do we impact the fiber manufacturing industries, everything from composites to apparel. How do we embed technology into fibers, not just attach it to our clothing once we've produced it, but how do we embed it into the fibers for either things that are going to be structurally woven materials and composites, or for things that are worn. So there's a lot of depth and breadth here that we'll try to bring in as examples throughout the class. And then, drilling back down in a little bit more closer to home at MIT. So I'm, as Jonathan mentioned, I'm the Associate Director of MIT Nano, in addition to my other hats. So MIT Nano is a shared facility on MIT's campus. We're just open now about a year and 5 months, so just under a year and a half. And it's dedicated, all 200,000 square feet, 50,000 square meters, is dedicated to either fabricating things at the nanoscale, or characterizing things at the nanoscale, or interfacing devices at the nanoscale to the macro scale. And you'll find, for example, conventional wafer fab equipment, but you'll also find roll-to-roll processing equipment or sheet-fed processing equipment that is a set of functionality that you would find in industry, but open to the researcher, so that we can experiment with materials, we can experiment with processes, and we can experiment with devices. So it's open to the entire MIT campus, but it's open to the world. We have a model that, with such a facility, if we want to really have the impact that MIT is designed to have, our impact is worldwide, and we want to engage the worldwide community. So this is a facility that we actively want to engage people that need to use it, and that does not stop at the walls of MIT, and it doesn't stop at the walls of Cambridge. It stops at the world. And so there are very interesting ways that we can engage with you and with others to help address and answer the questions that may benefit from being able to manufacture and fabricate at the nanoscale. Okay, this is a little bit of a backdrop of MIT. Very little bit on me. I do a lot of research at the intersection between academia and industry. My students are a mix of mechanical engineers, electrical engineers, computer scientists. And they join my group to really translate technology out into the marketplace. And so there's a lot of successful examples of how we've done that. But first, before we move on, So I want to have a poll just to get a good sense of who's listening and where your mind is. What you think are the most impactful things that are happening in the world. So the poll is of the following thing, and this is not an exhaustive list, but of the following emerging technologies. What is your opinion? There's no right or wrong answer, but what's your opinion of what just had the most profound influence on manufacturing? So I think the poll should have popped up by now. If the participants, you can just click the radio buttons, and we'll give you maybe 45 seconds to a minute, and then we'll show the tally here. I feel like I should have the Jeopardy music. We recently had the various champions of Jeopardy coming on, so I feel like I should have the Jeopardy music ticking away here. I think, Jonathan, if you can give me the cue as to when you think you or whoever is doing the tallying behind the scenes here, you can give me the cue when we should go to the next slide.
Yeah, see, and just for excuse me, for the participants who are posting your notes down in the chat, just recommend and put it onto the survey itself, and looks like we have the results. Excellent.
Okay, great. There we go. So we have sensors in at 21%, cloud computing at 8%, Internet of Things 17%. AI and machine learning, 34%, and data analytics, 20%. So thank you for that. It's very interesting, right? Because I think these things are not decoupled. They're all well connected, and so you can't get data without sensors. You can't process data without some computing. You can't sort of get communications with the sensors without some kind of connectivity, whether that be the internet or other communication channels or models. So they're not disconnected, but all of these things are certainly impacting not just our world in the things that we consume, the way we consume media, the way that we interact societally, but also in the manufacturing enterprise. So thank you for that. We saw the results. So ideally, right, what I'd really like to do in this class, I'd either like to visit you in your factory, or I'd like to bring you to a factory that we can work around different processes and look at the machines and the processes where data is coming from. Unfortunately, we're all around the world. We can't do that. So we have the benefit of modern technology to try to help. So I would love to be within the factory, but we're going to try to bring the factory to you. My prior life, prior to one of my prior companies, we specialized in high-speed video, and we did a lot of video analysis and video capture in the manufacturing environment. And I still do a lot of research in video processing and image processing. So I just want to give some examples of a little bit more of my history, if you will, of some of the minutiae and the details that I've observed on the factory floor. And I have these to convey just sort of the breadth of the types of different manufacturing processes that you may be interested in, but also to convey the breadth of sort of scope and scale with which you can approach manufacturing. And this is a high-speed video recorded at 10,000 frames per second of a laser weld melt pool. And this is a process that you can't imagine putting any sensor on it directly. The video the camera is certainly a sensor. Later in the class, one of the modules that you'll study is how do you use video, high-speed video, to extract information that is relevant for process control. Because otherwise, there's no way to easily put a thermocouple or any kind of fluid sensor into this thing that's being heated by lasers and melting. Just some other examples is a laser cutting process of aluminum, again at 10,000 frames per second. This is a wire-fed plasma welding operation. Slow now, only 5,000 frames per second. But again, this is at sort of the very focused process level, and we'll expand out to the factory level here in a few frames or a few slides. Here's an example of a milling operation. You can tell by the smoke that's going to come off in the video on the right that we're not using a probably not enough cutting fluid. But when you start looking at manufacturing processes with this level of temporal resolution, you can really start to better understand the data that's coming from these processes and how to optimize them. That's a milling operation. This is a binding machine operation. In situations like this, it's not just the appearance of the object of the machine or of the product that's relevant for knowing its quality. It's how things are moving around and the trajectories through time and space of how different armatures or cutting tools or pieces of fiber are connected to one another. This is a pill packing operation, so a robotic manipulator. We will talk a little bit about automation. We'll talk about quality control, process control in the class. But this is an operation that's taking a pill pack from a feeding operation and moving it to the next process in the sequence. This is a sewing operation, recording at 6,000 frames per second of clothing. This is a spray coating operation of various things, recording at various speeds, spray coating or a printing process, or an ink print at 250,000 frames per second. And if you're interested in the quality of painting or the quality of a coating, you can look at the final result. You can look for defects, but you're also going to want to control how the paint is deposited and how the paint is controlled, and the size and distribution of the particles that are coming out of the spray coat head before they get deposited onto the substrate, onto the flexible car panel or into the sheet metal. So this is now just, if you are sort of very interested in video, and we will again talk about this in one of the later modules, this is a paper that we put out now a couple of years ago, looking at using high-speed video for process control. This is a diaper packaging line. We see here there's a little bobble in the flow of the material, and what we'd like to do is detect that little bobble right when it happened, because if we don't detect it and stop the machinery, several cycles later, as we see here, the entire printer, there's a printer of a massive scale, jams and is blocked and causes serious sort of both downtime and expense. So that's one example of something that we'd like to do with high-speed video. And here's another one of product testing. This is a heart valve undergoing lifetime testing. The valve on the right is, on the left is when the valve is brand new, and the valve on the right is when it's beat several millions of cycles, recorded at high speed, played back at high speed, so you really can't see what's going on. But we'll use video in this case to compare the changing trajectory, the changing properties of the valve over time. Okay, so let's now expand back out, if you will, to the factory. And, those are some very sort of high-focused, sort of both in time and in space, of individual zoom-ins on processes. But now we look at all those processes across a factory, and we collect data. And that data allows us to say something about individual processes. It allows us to say something about material flow. It allows us to say something about human interaction. And we really have to start thinking about a factory as a data source in conjunction with it knowing its physical context. So one of the themes throughout the class is to have both a physical context in mind and a data context in mind. And you have to approach modern, smart, digital, Industry 4.0 manufacturing through both of those lenses. It doesn't mean that every individual has to know everything about data and everything about physical context, but you need to be able to speak the language, or at least know the words. And the graphic on the right is trying to highlight the different things that you can do with data, and highlighting the various ways you may be concerned about quantifying or classifying the types of data that you're acquiring, whether it's coming at you with high velocity or there's a lot of variety or large volume of data. You're going to want to make real-time insights, and you're going to want to do condition monitoring. You want to integrate different data sources, provide floor visibility into what's going on, do proactive maintenance, troubleshoot things. So all the ways all the things that you already need to do on a factory floor, but data, better sensors, better communication, better analytics can help you better plan, have better insight into what's happening, and make informed, information-driven, data to information-driven decisions. This little graphic in the bottom here, that's a little CAD drawing of with some aluminum stock, as expanded on this slide. I do want to introduce you to Fred, because Fred, with my abuse of acronyms, is an acronym for fiber. We take the F and the R from fiber, extrusion device. This is a tabletop 3D printer, if you will, but 3D printer for fiber. And we use this at MIT in a number of different classes. We use this to do research on fiber manufacturing, but it's a highly instrumented system that allows us to take material in of some type of polymer, heat it, extrude it, measure it, cool it, and wind it up and use it for something else. It has an extruder, it has a number of different measurement capabilities, a laser micrometer, temperatures, spindle rates, has a cooling system, which sometimes can be air, sometimes can be water, sometimes other coolants. And then it has a spooling system that accumulates the fiber, and you end up with the fiber as we're looking at in the bottom right corner. And Fred works by taking material and data in. We take raw polymer in, we take product specifications in, and what comes out of Fred is the modified material on a spool and a lot more data. The temperatures that were used to control production, the diameters that were made, the velocities of various components, whether it be how hard we're pushing the raw material into the extruder or how fast we're winding it when we're coming out. But we'll have some physical intuition. I'm sure many of you, when looking at this, if you think a little bit about it, can come up with a mental model for the physical intuition and have some expectations for how this thing works. And maybe you're familiar with an extrusion process. Now, throughout the class, we'll come back to Fred in various ways, both a single Fred and multiple Freds and the sensors that are on Fred. But we'll use it to provide at least some common language and a common factory, if you will, because I know, depending on where you are in the world and what your background is and where you're working, you're not doing fiber manufacturing. You could be doing semiconductor or automotive. And the things that we're going to learn using Fred as that vehicle are going to be applicable to all those different manufacturing enterprises, but it's a convenient way for us to have a common understanding, a common physical context to relate our physical intuition and the data intuition that we'll glean throughout the class. So just another couple images. Again, the CAD drawing on the far left, an early version of Fred with sort of the wires visible, if you will. So it's certainly it's been made in the basement of Building 35, where again I'm sitting today. You can see, if you look closely, depending on the resolution of your monitor, you can see the fiber, maybe not coming from the extruder head, where the red and the yellow wires are attached to the top of the center image, but certainly there's a thin band that is leading to the spool at the bottom that's passed through the cooling system. And there's a bunch of motors and coders and sensors that are telling us how Fred is performing or controlling how Fred is moving. And in the end, again, we make this spool of fiber on the right. So you can ask, I think coming out of today's webinar, if somebody were to ask you, define smart manufacturing. That's not an easy question. It's a confluence, it's a combination of a lot of different innovations that are happening right now, that are all coming to maturity right now, benefiting from the semiconductor industry's steady march to sort of lower trace size and make better electronics, better communications. But it's sensors, it's cloud computing, somebody else's computer. It's the Internet of Things, the connection, the internet connectivity of other things other than our conventional computers. It's AI and machine learning, it's data, big data. It's 3D printing, additive manufacturing, software as a service, robotics, data analytics, algorithms of various sorts, and more. Right? So in all these things, there is both a physical context and a data context, but it's smart manufacturing, as at least I define it, and the way that I'm going to approach teaching it in the class that you're going to partake on is a collection of these technologies. And we're not going to cover all of them with the same level of depth. We'll touch on some, but help you to develop the confidence and the understanding of how to break down from a joint physical context and a data context, looking at any of these different components, if you will, of a smart manufacturing enterprise. So the smart manufacturing processes, the way that we're going to weave our way through the next handful or two handfuls of weeks. This is not mapped to individual modules, but let me just give you a feeling. We'll roughly build up from small scale to big scale. right? So we'll start with an introduction, give you a flavor for what's happening globally, what are the trends that are happening in society, what are the trends that are happening in the demands that as consumers we have on products, and what's happening in the factory. And then we'll get into the factory. And so what's happening in the factory? We'll start with an understanding of sensors and how we acquire data and how we make sure that our sensors are matched to how we acquire the data and the rates that we acquire the data. So start with sensors and data acquisition, and then use that to talk about, well, how do we control processing? How do we do feedback control? How do we do real-time feedback control at a very fast time scale, which maps back to the sensors and how we acquire our data. And throughout, when we look at sensors or we look at manufacturing feedback control, or we are out to machine vision, we will periodically be asking you questions about, well, how do you take what you've seen and learned so far and suggest how we improve Fred? What's wrong with Fred given the current set of data that you'll be presented from Fred, or your physical intuition for Fred? How can we improve Fred based on how we're seeing it perform? And so that will be some of the exercises to try to use Fred and control Fred and acquire data from Fred. And you'll see real data coming from Fred, from the fiber extrusion device. And so you'll use that increasing knowledge to hypothesize and to suggest machine innovations and machine improvements. Then we'll move on to machine vision, various applications of machine vision, and we'll also be exposed to different areas where smart manufacturing technologies are applicable outside of manufacturing. And then we'll get out to both now, instead of just feedback control, statistical process control, where the goal of SPC, of statistical process control, is to get to the point where everything is purely random, that we've eliminated deterministic noise or deterministic variation, and we're left nothing but random noise. And then moving on finally to the types of advanced analytics that are only possible once you've acquired lots and lots of data, but that in the end give you information about the things that are coming from our sensors, or how we can improve our feedback control, or how we can do machine innovations, or how we can improve quality and rate and cost in the products that we're making. So that'll be at least my 30,000-foot view of the journey that we'll take. And we've now mapped that to a series of weekly modules. And I think with that, just to maybe give you sort of another lens into how we've structured this, I'll turn it back over to Jonathan to sort of walk through the various modules in the course overview.
Thank you, Brian. So participants, I will be your course leader for this course, and we'll also then have another learning facilitator, Sergio, that would be joining us for the duration of the course. And so we act as the liaisons with respect to the content. I'll get more into how that relationship works in some of the subsequent slides. For now, this is the structure in terms of the first half of smart manufacturing. We begin by looking at the introduction of kind of what is and somewhat what is not within the scope of our course, and then describing how Fred works. And there's some really great videos where we see Brian in the lab with some of the students that have helped to build Fred and evolve it over time. And so that's a good way to sort of understand Fred as a prototype, as well as those global trends in smart manufacturing. We then get into one of the key facets of smart manufacturing, which is is analyzing the data and how to visualize that. So this is looking at convergence of manufacturing and data science. So from analyzing time series data with Excel, if you have programmatic experience, such as with Python or R, you may also find sort of a leg up in terms of being able to handle some of the data that Fred generates. And we'll be keeping some of that cadence of working with data from Fred over subsequent modules. So in that third module is modeling to make sense of this data. So how to build the models to improve Fred. So we're hypothesizing about where are there issues, and how might we be able to fix those on the machine. And then we're exploring those effects of extended production runs, and we're using real data from the device. And so it's really exciting to be able to work with some of the messiness of real world data. We then get into a segment on sensors. And I see from the chat a little bit earlier, a couple minutes ago, there was discussion like, well, sensors is kind of enabling so much of this. I mean, absolutely. So we look at that integral role of sensors in smart manufacturing, where and how we're deploying that across so many different aspects of different industries of manufacturing. Because it's not just about making widgets. I mean, we may be in a medical context, we may be working at a nano scale. And so there's a way to evaluate the sensors and assess the different kinds of data that they would produce and what to do about it. Rounding out the first half of the course is module 5, where then we get into the control of manufacturing processes. So some of the points that Brian had raised earlier in terms of looking at process control and feedback and modeling, monitoring, and then looking at the actual sort of performance versus what we predicted, and sometimes the tension or hopefully a copacetic relationship between forecasted and predicted. So now then moving into the modules 6 through 10, the second half of the course, we then go into 2 modules of machine vision and the applications thereof. So that module 6 on machine vision, we're looking at if we have a camera, how do we take test measurements? How do we use cameras and images to really inform our decisions? Because at the end of the day, that's what's most important, is how to inform and make better decisions. Then in the module 7, it's the applications of machine vision. So we're looking across a variety of industries, and you'll be challenged to go look at an industry area of interest to you, and to explore those specific applications, report back your findings. When we complete the machine vision component, the module 6 and 7, then we're kind of teed up to be able to go into model fitting and sensitivity analysis. So we get back into some of the heavier lifting of data with this module, making that connection between the machine vision that we're just kind of coming off from and getting ready for statistical process control, SPC. It's really about discovering the best fit of if we have a big chunk of data, how do we, as simple as putting down a trend line, what are some of the mathematics behind that? How do we do that in a sort of a responsive way so that we get a good fit? The module 9 is about SPC. And when we're applying that statistical process control to a manufacturing setting, there are concerns and considerations. So some of the specifics of that is looking at how to integrate deterministic and random variation sort of factors into our analysis. And finally, as the kind of capstone of the course, in module 10, we get into advanced data analysis. So these data sets are derived from the manufacturing process to control the machines. And we start to then get you ready for how to explore the concepts in cloud computing. So broadly, this course really touches on a variety of different topics across multiple industries. And it's not, I'll venture to say it's not possible to capture everything in one course. However, what I do feel we have done well is to be able to get you set to then across all these different areas, across all these different modules. Then after the course, you'll have a sense as, you know what, I was really interested or found a lot of value in module 1, 2, or whatever, and then you can go deeper on that through, whether it's through MIT professional education or on your own independent learning. This is a good time to talk about the target audience of who could be a great fit for this kind of a course. Well, this course exposes you to technical details to help you appreciate the power and applicability of the smart manufacturing tools and concepts. So for those of you who are new to smart manufacturing concepts, our intention is to have designed it so that it is highly accessible with that. And for those of you we know who have considerable experience with these concepts, we expect it also to be, in prior versions of the course, we found it to be a valuable resource for those of you who do have some of that incumbent experience. There are officially no prerequisites for this program, and I'd say that, well, the sort of unofficial prerequisite is a willingness or to get to work with data, and that may be something as familiar as Excel, and then we help sort of provide guide rails around that, and some elastic help, I might say. So if you need a more help in sort of getting going in terms of how to manage, say thousands of rows of data, let's say in multiple columns, well, the learning facilitators, so myself included, will help you to get going on that. If that's already easy peasy for you, then that's awesome. Then you can challenge yourself in some other ways, and perhaps using programming languages to help do it fast and more pliable for your specific use cases. Yeah. Now, moving a little bit more.
I guess I would just add, Jonathan, just for a moment. I think, as Jonathan highlighted, he's one of the phenomenal learning facilitators, and as well, we will be doing a number of I will be doing a number of live webinars throughout. So there's the day-to-day facilitated interaction with the subject matter experts such as Jonathan, but you'll hear from me periodically as well throughout.
Absolutely, a great point. It's not just me. Brian Anthony is actively involved in the course with some of the webinars, and so this is a way for, in terms of, say, specific job titles or whatever, career professions that would make sense for this course. On the next slide, we mentioned that that the target audience would include technicians and engineers, and say plant managers who are working in manufacturing, or these manufacturing design engineers themselves that want to learn more about data and modeling in that manufacturing environment. Data scientists we've had in the past, looking to apply their craft in smart manufacturing. Certainly it's a blossoming opportunity, and absolutely would make sense as part of this course. But also technicians and engineers or leaders thereof, tasked with deploying a certain set of buzz phrases, but doing it in a way to get past the buzz phrase of Industry 4.0 and smart manufacturing. What is it? We're making it more concrete so that you can deploy this in your organization. Consultants, especially who are working in manufacturing settings or for manufacturing clients, would gain by understanding and sort of getting their hands a little bit dirty, so to say, with working with this kind of data. And finally, broadly, functional and cross-functional teams are part of our intended audience for this course. So the key aspects of this course, we can divide it into roughly 4 high-level areas. The top 2 are an application, so about Fred, and industry examples, and then we also have the guided learning and the peer learning. So specifically with the application with Fred and the iterating on a smart machine. This is where Brian has done an awesome job in terms of explaining the basic tenets of smart manufacturing, and then seeing how he and his team of researchers have been continuously improving Fred software and hardware components. And participants in the course are kind of taken along as active participants in the ride to see how data might change as we stress test parts of Fred over the course of that 10-week duration. We absolutely will look at industry examples of applications, so exploring how smart manufacturing principles have had a real impact in a variety of contexts, but some of my favorite are those that come from Brian Anthony's background in sports and medicine. This course is designed with guided learning, so it says on the slide that we explore with expert learning facilitators, and so roll myself in with that is that I strive to help bridge the concepts that we might be learning in the course to what each of you as participants may be seeing or trying to hope to deploy in your organizations or throughout your lives. And finally, a really crucial part of this is that peer learning. The peer learning that enables you to be able to work with across all the other folks that are also participating in this course. You'll be with some really amazing peers, so make use of that. We provide opportunities to do so. Now, in terms of how is it delivered? Well, it's in general, it's weekly videos followed by knowledge checks and assignments. And we have that kind of cadence across each of these modules. So Dr. Anthony is totally kind of the keynote of each week. And so we have detailed visuals around the physical, mechanical, mathematical elements of manufacturing. These are delivered by video from Brian Anthony. And so these lectures are very well done. And what they provide is a great base of knowledge that then we can help us challenge you to assess yourself through weekly knowledge checks. Then you'll be challenged to create your own visualizations throughout a number of the weeks of content, analyzing real, actual production data from Fred, and then getting a sense, sort of like a mental framework of sorts of how to make decisions around manufacturing processes. We do have assignments. This is a class, and this is MIT. So we have sample assignments. We're working with production data. For example, you may be calculating a moving average, plotting amplitude, or creating a variety of different types of histograms and time series and frequency plots, and doing this to compare predicted versus actual behaviors, for example, or closed loop and open loop systems. Then there's the evaluation of sensors for accuracy and repeatability, and understanding how different sensors would provide some of that, some nuances to that. And then there's that identification and evaluation of sources of variation in a manufacturing setting. And with Fred, or in most any type of manufacturing environment, you have some of the same qualities to be looking out for: variation, raw materials, equipment, the operator, and environmental, and beyond. So we give some structure around how to think about that. With the facilitators ourselves, so I'm Jonathan, hi, and then Sergio would also be joining us. And these folks are experienced in engineering and manufacturing pedagogy. So I'll actively moderate the discussion boards, responding to any participant inquiries around the content. And also, each learning facilitator, we host weekly office hours. And so this is an opportunity for you to hop into your specific learning facilitator's office hour, or any others that are going on, because we covered sometimes different content or different ways of communicating the content to help review assignments, as well as finding industry examples that we think are relevant to you and your peers. Now, in terms of some of you may be taking this course for so like engineering credit, or like accreditation as part of your professional continuing education, or some others for fun, just to better yourself. And so this course supports each of that. There is a certificate of completion if you complete 80% of all the required activities, and then you would be provided a certificate of completion. We give that out as a blockchain certificate, and you can display that wherever you would please. So social media, especially places like LinkedIn and other digital spaces, could be a great place to assert your achievement, because it's no small feat. Next is the MIT CEUs, or continuing education units. Participants are awarded 6 continuing ed units toward your professional development. And so that goes toward professional certification, licensing requirements, or some other required training that you may have. It depends on your training department or licensing authority. But if that's a need, you're probably already familiar with how it works. And thirdly, excuse me, we offer something, a very MIT thing, the MIT Professional Education Fire Hydrant Award. And so there's a saying that we share around the Institute, and it's that life at MIT is like drinking from a fire hose. And so this is a kind of award for those who demonstrate the MIT values and excellence during our program. And this Fire Hydrant Award is given out as a blockchain certificate, kind of like the completion certificate. And Well, just know that it exists, and it's for really active participants who really contribute to enhancing our community, just like we have, just like we value here on campus. A little bit of a description, contextual in terms of what is MIT professional education. Well, this program is a gateway to MIT knowledge and the expertise for professionals globally. What we regularly do is we connect industry with the latest in MIT research, knowledge, experts for anyone who's engaged in science and technology worldwide. And this is through the advanced education programs that are designed for the working professional. We have those folks in mind. We offer what we call the lifelong learning opportunities. So it's directly for you and for your organization, whether it's on-campus learning or online, like we're talking about today, or at an international location, and sometimes even on-site at your company. And MIT professional education has been here for quite a while. So we're founded in 1949. It's been 70 years now of lifelong learning. We are hosted under the auspices of the MIT School of Engineering. This is, by principle, everything is faculty taught, faculty led, and that's why you see such high engagement with awesome professors like Brian Anthony. The MIT Professional Ed is a gateway to sort of other non-degree and even non-credit programs for professionals, and these include short programs, which are in person at MIT, the custom programs, so large organizations sometimes have special needs. Then there are international programs where we bring the course content to you at a global location, and the digital plus programs that are part of our online portfolio. And finally, there's the advanced study program, and this is sort of like for working professionals. They would bear MIT credit. And so
And just to add that the advanced study program is an opportunity for people to come to campus and take courses on MIT's campus as well.
Great point. Thank you. Thank you. And so, now that we've explained the course as well as MIT professional education, kind of hopefully where kind of all the different pieces come together, it would be so great to have you as part of our professional education course and exploring the smart manufacturing together. We'll open up the floor to Q&A, and I see that many of you have found the Q&A box in Zoom, but to clarify where it is for all of you, on the Zoom toolbar, there is a section that says Q and an ampersand and A. You click that, and then you can post questions in there, and then Brian or I will go through and clear those questions by giving you hopefully helpful answers. So let's take a look at some of the questions that we have in there. And Brian, do you have any other words you'd like to add?
I just wanted to say I thank you, Jonathan, for helping with that overview, and I look forward to interacting with everybody online and folks that are maybe seeing this after it's been recorded. And we're trying to give you the language. We won't be able to touch on every single field and every single problem that you're interested in, but to hopefully provide a strong sort of update or new sort of understanding of this joint context between sort of a physical intuition and a data intuition. So I also throughout the class will welcome your questions and your feedback and ways that in the future we can iterate and improve what we do, or maybe there's a second course that we should be developing that would be a more advanced version of some of the topics. So I welcome sort of both positive and critical feedback as we go.
Yeah, great point. There is a link to register for the course that's been added to the chat. So that's a little bit.ly link. Follow that to register. Now I think would be a great time to answer some participants' questions here, and we have a couple on terms of specific content that sort of may or may not be within the bounds of this version of the course. And so, Brian, we have a question with Onos is that Ono said that, well, I was thinking about these topics on a higher level and it lists 4 different concepts like industrial IoT, and industrial protocols like OPC UA, ProfitNet, digital twin simulation, and SCADA, or MES. Could you clarify on sort of some of the topics that we would cover and why not for this course?
Certainly, and thank you, Anu, for the question. So to try to answer as best I can here, and we talk a little bit about the various aspects of the infrastructure. And infrastructure includes both sensors and communication, analytics, AI, and machine learning. And we don't want to focus too much on specific industry providers per se, but want to make sure that you have the ability to critically evaluate. Well, should I look at a solution that's an open source solution, or should I look at this sensor versus this other sensor? What are the attributes and the properties that I should ask and when comparing either a sensor or an algorithm or a communications profile? We won't talk in detail about specific communications protocols, but again, to explain what the intent of them, and you'll be able to then critically compare different approaches. We would talk a little bit about the digital twin. Digital twin is nothing more than a model, a simulation model, and that can be both physics-driven and data-driven. So that's certainly an area that we talk about. Supervisory control and manufacturing execution systems. We'll talk about those in sort of the context of how they sort of stack from the various time scales of manufacturing processes. We're not going to dig detail into specific manufacturing execution systems or supervisory control systems, but you'll be familiar with the technologies that go into them. So hopefully that tried to answer your question a little bit, Anu, and certainly can answer more offline if that would be helpful.
Great, thank you. So what I was going through and I answered another question in terms of say like market available sensors. Do we get into the specific manufacturers of sensors for industrial applications? And I made a note that there's one assignment in particular where participants have an opportunity to look at specific types of sensors, and if they want to go to the level of detail of a particular manufacturer or SKU number, they have an option to do so. We have a question sort of just in terms of manufacturing overall from Ryan about how would the future of technology and robots affect jobs for your quote average factory laborer, machine operator, or welder? Would we see a significant decrease in the kind of job demand for a factory laborer?
It's a very interesting question, and we could talk about this very question for a very long time on its own. The nature of manufacturing jobs is certainly changing, and I hope that's probably why some of you are listening and considering taking this class. How do you level up your knowledge and your skills? There are plenty of manufacturing job openings. Companies are having a hard time finding people to fill jobs, and so that's one of the drivers that many companies are looking towards automation, that they can't find the labor that they're looking for, so they think about how to automate. And at the same time, once you introduce new and increasingly complex technology, you need people at all different educational levels and all different levels of familiarity to control the systems, to repair the systems, they're never going to be completely autonomous. People are always going to have to maintain and improve and monitor and use them. So the nature of the job, the nature of work in manufacturing is changing. So I don't think it necessarily is going to decrease, but it certainly will change. And I hope in some small way that this class can be one step on that journey to helping the participants and others that will take it in the future continue to level up and take on the internal drive to acquire new skills, to maintain the opportunity to stay employed in that sort of vibrant space that is manufacturing, because it really is. It's a hard space to live in, because you have to deal with people and data and systems and processes, and a constantly evolving pressure to increase rate and quality and cost with using technology. So I don't think it's going to decrease. It just gets increasingly complex and requires more training, more education, which hopefully this class can help you with.
Great, thank you. I have a question from Jorge about what's the approach of data analysis in terms of process KPIs, so key performance indicators such as OEE, cycle time, downtime, availability, process performance, scrap, etc.
Right. So you'll understand we're not going to talk we're not going to focus in particular on cycle time or downtime or availability, but we'll say, well, if I have data, right, that may either be something that came from a person's log or something that is coming from the equipment itself, how do I process that, and how do I set the control limits and ask the questions? Well, if I have this data and I want to know about downtime or I want to know about scrap, that's information that's embedded in the data. And so the hope is to give you the tools to approach getting that information out of the data to make those evaluations on whatever your KPIs may be, your key performance indicators, whether it is OEE or cycle time or downtime or other things that are industry or product specific. So you'll have the tools and be exposed to the tools for how to analyze and how to evaluate the various metrics that are relevant to your particular factory.
Thank you. I see a comment about from Nano. Would you recommend any other course if some topics are not covered, and how to handle, like, suggestions around the topics that since there's so many in smart manufacturing, and how to guide a participant in terms of getting the kind of knowledge that they would seek?
I guess it depends on what type of additional materials that you want to study, and there are plenty of papers and books and other courses that would be available. But I guess it kind of depends on what, if you want to go into a more advanced or more focused, you need to know a little bit more about what those topic areas might be. So maybe that's a follow-up question. But at the same time, as I did say, I'm very interested to hear feedback both from today and throughout the course on areas where, as we see there's a particular demand. I do look forward to developing the advanced versions of this class that maybe are focused on particular areas and need some data to get to the actionable information that tells us what are the most relevant and more advanced classes to make available to the community.
Great point. We have one question at the top from Luis. It's regarding how is it possible to introduce e-tech into public policies or governmental structure? And I understand this is generally a little bit out of the scope of a course on smart manufacturing, though it is sort of part of the greater context of the worlds in which we live. Do you have an opinion on that? How to introduce some of these technologies through public policy?
I mean, I guess I would take it from the perspective of if you are somebody that is acting in that public policy and governmental space, then this could be a good way so that you become familiar with what is happening, what are the current trends and opportunities. So to be maybe fully informed and having those policy decisions or governmental structure decisions made. We're not going to talk about sort of public policy and governmental structure in the class per se, but if you are a professional in that space, I think this could be valuable to you so that you understand the nuts and bolts and the components that may make sense to think about how you go about deploying sort of a workforce training program, either for a community or for a particular company. And making things both available for veterans or for the incarcerated. That could be some very interesting thought, but that's not at all my area of expertise.
Okay. We have a question from Karsten about how do you see the relationship between high fidelity video analytics and cloud computing?
Interesting question. So it's always rapidly changing. There's certainly this question makes me think about what's the computation that you put at the edge, meaning right at the data source, versus piping the data, the raw data, to some central computer. And there's always going to be a trade-off in that. And when we talk about high fidelity video, you have to talk about it both from do we mean fidelity in spatial resolution or temporal resolution, or what's the gigabits per second rate that you're trying to deal with? So certainly cloud computing is amenable to some scales and some rates, but at the same time, when it's high speed enough and fast enough, it's still prohibitively expensive to do anything other than computing at the edge, meaning having the computation available for you on the factory floor. And we have the benefit of the gaming community and the production of GPUs that really makes sort of local edge processing at least technically feasible. But although sometimes always you'll have to consider the cost constraints, but sometimes too many GPUs can start to cost you more than you may want to spend. But yeah, it certainly in any of these techniques of data analytics, there's always going to be the question of what's the processing that happens at the edge, at the point of data collection, and what it makes more sense to offload someplace else. And often the someplace else is going to be the type of processing that can benefit from having the data aggregated over a lot of data from a lot of time or a lot of locations. And if you can do a sort of a real-time decision at the factory floor, on the factory floor, then you probably want to put your computation there.
Thank you. A question from Ramon asking that, saying that he says, I work in a traditional manufacturing environment and we carry out automated forging followed by machining on an automated line. How relevant would this course be for me? And P.S., we do not have Industry 4.0 standards.
Well, I think one of the messages that I try to convey through the class is, in some sense, Industry 4.0, smart manufacturing, it's new and it's not new, right? This manufacturing, you've been doing process control, feedback control, inspection for a long time. We know how to do these things. What we're able to do now is do it more, better, and faster, cheaper, hopefully. So the things that you do already, right, where you are doing some type of automation and you're inspecting, those are, without a doubt, components, technologies within the Industry 4.0 or smart manufacturing or digital manufacturing house. And I think if you want to be the agent of change in your environment, in your factory, highlight the fact that, hey, you're already on this journey. Maybe it's very early, but you have the maybe ad hoc, but you have the underpinnings of Industry 4.0. So take it as your initiative to say, well, here's how we think about this in a contextual whole, and here's our approach to moving from where we are now, where you're not currently deploying a particular standard, but to maybe be the change agent for leading that conversation and guiding that conversation within your enterprise.
Excellent, thank you. I have a question from David asking, does the scope of the course cover defining system boundaries for applications of analytics? Asked in another way, will I be able to apply the learnings from this course to individual machines as well as systems of unit operations?
Yes. So we will talk about both Fred in isolation by itself, and once you have data from multiple Freds, and how do you go about analyzing a single machine or a collection machine and then classifying the properties that are coming out of data that's acquired over time or across multiple machines or across an enterprise.
Okay, great. With respect to time, we have gone a little bit past the top of the hour. There are, let's see if we can get through a couple more of these questions. The most pertinent ones being, from Joe, the top of the list. How pertinent is this content to assist me in providing basic instruction on Industry 4.0 to secondary education level students?
That's a great question. So I think if you want to try to convey things such as sensing and analyzing data and how do you think about the sort of modeling physics and relating sort of data that you've acquired to modeling of physics? The material through the lens of an educator can be scaled up and scaled down. So I think it'd be very helpful to assist you in providing instruction to primary and secondary students, taking your expertise and how to relate that knowledge to those age levels. I think it will be very accessible material that you'll be able to acquire and pass through your lens to help your students.
Okay, great. So we have 4 questions and do it in order of priority. From Laith, we have a question of how can such industries like the 4th Industrial Revolution benefit third world countries? So could rudimentary industry knowledge, walk before it crawls?
Yeah, you have to start someplace, right? And again, there probably are very few manufacturing enterprises that aren't doing the very rudimentary, basic components of smart manufacturing, but just not doing it in the holistic, controlled way. And so, just understanding where you are in this journey and how do you better use the data that you're already acquiring, and looking at the accessible technologies, and whether that be computing on an iPad or on an iPhone, there are plenty of ways that I've seen sort of the less developed industries in less developed regions around the world really creatively start to apply the principles, if not the sort of the complete hierarchy of formality. Because of the way that costs are going and the availability of technology, whether it be sensors or computing, or the communications devices that allow us to get data to somebody else's computer, I think there is an interesting opportunity for industries and for economies that are not as developed to not completely leapfrog, but to certainly accelerate their adoption and use of the technologies they'll learn in the class.
Great. Okay. There's a comment from Yao. The application industry examples says is underwhelming in the sense that it does not include some of the broadest industries, namely F&B and personal care. Is this course applicable for the latter? And I must say I'm not familiar with F&B.
F&B, personal care. So yeah, that I got. But so we're not talking about the production.
Food and beverage.
I'm sorry, food and beverage. Food and beverage.
Yeah,
food and beverage. Yeah, food and beverage and personal care. So we will be the tools that are used, right, the data analytics that are used are certainly applicable. We're not using data from a food production line, or we will actually look at some bottling lines in some of the videos. But yeah, we don't use these as these are harder examples to sort of present. I can't give you a direct data from a personal care production line or a food and beverage line. I guess I could do maybe food and beverage, but I mean, one of the reasons we used Fred is it's a very accessible thing. So depending on where you are and your understanding of either physics and physical intuition, it's a nice accessible way. But the tools, it's not so much about the fiber that we're producing. That just gives you a context to make it real. The data could come from the flowing production of quality control of a particular beverage or of a particular food, or of razors for that matter, personal care. And so I don't as much think about, it's all about Fred and it's all about fiber. That's the convenient platform. The tools are broadly applicable. So I hope that answers the question. But as well, when talking with the learning facilitators, you should bring in the data that you have or other examples, and we can certainly make accessible other data from other industries, and to help guide you through how to use the same tools to process data from other sources.
Okay, and then there's 2 questions. One is on sort of post-course follow-up, and what's accessible to the students after the course concludes. I know that the content itself remains available for quite some time, months afterward, and and then beyond that, I think it's a sort of a different relationship once the course concludes. Could you speak on that a little bit?
You'll be receiving lots of material as well that you'll always have. You'll download data, you'll download assignments. You'll always have that material as reference. That doesn't go away.
Okay. Yeah. And last fun question. In what direction do you think fashion trends will go with new fibers?
Very, very interesting. I guess it makes me think. I was recently at CES in Las Vegas. That's the Consumer Electronics Show. And I guess I noted a couple different things. One, there were probably, within one of the convention halls, there were probably 5 different smart toilets and 6 different smart couches, and probably 8 different manufacturers of different types of smart clothing, athletic wear, baby wear. And so it's already happening. You're putting technology currently on our clothing, right? It's not yet integrated into the clothing, but I think it's just a matter of time before some of the technologies that are in the lab and in research are going to start to come out, and you'll see smart fibers. You'll see things that you can't, when looking at the apparel, you won't think that there's a sensor there because you won't see it on top or as a patch, but it'll be integrated in part and parcel of what you're wearing, and whether that be for smart bandages or physiological monitoring of athletes or of people that are for wellness and health. That's the direction, and it's just a matter of time, I believe.
Fantastic, thank you. So for all of you, we appreciate your time and great questions, all of you. You have information if the course sounds like a great fit for you. We'll be glad to have you aboard. Thank you, each of you, so much, and thank you so much, Brian Anthony, for your time.
Jonathan, thank you, and everybody have a good day, night, evening, wherever you are in the world. So thank you. I look forward to interacting with you in the future.
Bye-bye.